Hello everyone, welcome back to English Pathway Learning. In today's video, we're going to be learning about science. Science, unlocking the universe. This is an exploration of humanity's greatest pursuit, from ancient observations to the cutting edge of discovery. Why science matters. The engine of progress. Science is humanity's relentless, systematic pursuit of understanding the natural world, from the smallest subatomic particles to the vast expanses of the cosmos. Science seeks to explain why things happen, how they work, and what they might become. It's not merely an academic exercise. It is the very engine that drives civilizations forward. In innovation and technology, every modern convenience, from antibiotics to smartphones, owes its extensive to scientific inquiry. Science transforms curiously into tools that reshape everyday life, making it safer, longer, and more connected than any previous point in human history. Solving a global challenge. Solving global challenges. Climate change, pandemic disease, food scarcity, and energy demands are among the most complex problems of our species has ever faced. Science provides the framework, the data, and the solutions required to confront these challenges with evidence-based confidence rather than guesswork or ideology, shaping our future. From renewable energy to gene editing, the discoveries being made today will define the world tomorrow. Science empowers us to make informed choices about the kind of future we wish to build, and give us the tools to build it. A scientific method, a framework for discovery. At the heart of all science progresses lies a deceptively simple but extraordinary powerful process, the scientific method. Rather than relying on intuition or tradition or authority, science demands rigorous, repeatable, and testable evidence. This structured approach ensures that our understanding of the world is grounded in reality and constantly refined as new evidence emerges. Observations. Noticing phenomena in nature. Hypotheses. Forming a testable prediction. Experimentation. Designing and running controlled tests. Analysts. Interpreting and evaluating data. Consulting. Drawing insights and refining theory. The scientific method is not a ride checklist, but a dynamic, iterative cycle. Scientists often loop back through these stages many times, revising hypotheses, refining experiments, and challenging conclusions before a robust understands emerging. This self-correcting this self-correcting nature is one of science's greatest strengths, ensuring that errors are identified and knowledge is continuously improved. Peer review, the process which fellow scientists scrutinize and challenge public findings, is a critical safeguard that maintains the integrity and reliability of scientific knowledge. A revolution in understanding key breakthroughs. Throughout history, certain discoveries have fundamentally altered the course of human civilization. These breakthroughs did not merely add to existing knowledge, they shattered prevailing assumptions and opened entirely new frontiers of inquiry, technology, and possibility. The double helix. Watson and Crick's discovery of DNA's double helix structure, and arguably the most important biological breakthrough of the 20th century, by revealing how genetic information is stored and replicated. It laid the foundation for modern genetics, genomics, and molecular biology, ultimately enabling gene therapy, personalized medicine, and forensic science as we know them today. The Internet, late 1960s, present. Born from ARPANET, a U.S. Defense Department project of the late 1960s, the Internet has become the defining infrastructure of the modern age. It democratizes access to information, connecting billions of people across the globe, created new economies, and fundamentally transforming how science itself is conducted, enabling instant collaboration across the continents and sharing a vast of data sets in real time. The Higgs Boson, 2012, discovered at CERN's Large Hadron Collider after decades of theoretical predictions and experimental effort. The Higgs boson confirmed the standard model of the particle physics, our best current description of fundamental forces and particles that make up the universe. The discovery explained why particles have mass completing a critical piece of the cosmic puzzle, and validating one of science's most ambitious predictive frameworks. From bakers to big data, the evaluation of scientific tools. The tools available to scientists have undergone a breakthrough transformations over the centuries. Where once researchers' entire laboratory might consist of glass breakers, candles, and hand-drawn notebook, Today, scientists command electron microscopes, Gini squarances, particle accelerations, and artificial intelligence platforms capable of processing billions of data points in seconds. The vintage laboratory. Early scientists worked with rudimentary but ingenious apparatus, Bunsen burners, hand-ground lenses, and chemical reagents mixed by hand. Despite these limitations, pointers such as Faraday, Pasteur, and Curie achieved discoveries that still underpin modern science. Careful observations and meticulous record-keeping were their most powerful instruments. The modern research environment. Contem Contemporary laboratories are environments of extraordinary precision. Clean rooms element microscopic contamination. Robotic platforms run thousands of experiments simultaneously. Supercomputers model complex biology or atmospheric system with stunning accuracy. The rise of big data means that a single genomics project can generate more data than all scientists literature published in the 19th century combined, demanding entirely new approaches to analysis and interpretations. The transition from analog to digital science has not just accelerated discovery, it has made entirely new categories of questions answerable for the first time. Science in action, tackling global challenges. Science is not a purely theoretical innovator confined to ivory towers. Its most profound purpose is practical: to equip humanity with the knowledge and tools needed to solve its most pressing problems. Three of the most urgent challenges of our age: climate change, disease, and food security, are areas where science already delivering transformative results. Climate change. Climate science has provided unambiguous evidence of anthropogenic global warmings, while materials science and engineering are delivering the solutions. Solar panel efficiency has improved over 400% in 4 decades. Wind turbines now supply significant portions of national grids. Climate modeling runs on some of the world's most powerful supercomputers. It is helping the government predict and adapt to extreme weather events, rising sea levels, and shifting agricultural zones with increasing precision. Disease eradication. Vaccines have eradicated smallpox, nearly eliminated polio, and dramatically reduced the burden of dozens of infections. The mRNA vaccine technology deployed against COVID-19 deployed in record time thanks to decades of prior scientific investments, heralds a new era of rapid response medicine. Gen therapist is offering hope for previously untreatable genetics conditions, while advanced diagnoses powered by AI are detecting cancers and diseases years earlier than it was previously possible. Food security. With the global population projected to reach nearly 10 billion by 2050, feeding the world sustainably is one of the defining challenges of this century. Arguable science is meeting this challenge through precision farming and guided by satellite data, drought resistance and high yield crop variations developed through genetic engineering and suitable protein alternatives, including lab-grown meat and insect farming. These innovations aim to increase output while dramatically reducing environmental footprint of food production. The human element, scientists shaping our world. Behind every great discovery is a human being, driven by curiosity, shaped by their error, and often working against formidable obstacles. Science is not made by in situations or machines alone. It is made by individuals whose courage to question, persist, and challenge prevailing assumptions has repeatedly changed the course in history. 1. Marie Curie, 1867 to 1934. Marie Curie remains one of the most remarkable scientists in history. Born in Warsaw at a time when women were barred from higher education in Poland, she pursed her studies con, con, covertly before moving to Paris to earn degrees in both physics and mathematics. Her pioneering research to radioactivity, a term she herself coined, led to the discovery of two new elements, polonium and radium. She became the first woman to win a Nobel Prize and remains the only person ever to win Nobel Prizes in two different scientific fields, physics in 1903 and chemistry in 1911. Her work did not only transform our understanding of atomic structure but laid the foundations of nuclear medicine and cancer radiotherapy. 2. Albert Einstein, 1879 to 1955. In 1905, his so-called Annus Mirabilis, or miracle year, a 26-year-old patient clerk named Albert Einstein published 4 papers that would reshape physics forever. His special theory of relativity introduced the same revolutionary idea that the laws of physics are the same for all non-accelerating observers, and that the speed of light is constant, leading to the famous equation E equals mc2, which demonstrated the energy and mass interchangeable. His later general theory of relati- relativity remained gravity, but not as a force, but as a curvature of space-time caused by mass. Einstein's theories have been confirmed by countless experiments and underpin technologies including GPS, satellites in navigation, which must account for for relativistic time dilation to function accurately. The date, Deluc, fueling tomorrow's discoveries. We are living through an unprecedented explosion in scientific data. The Human Genome Project, completed in 2003, took over a decade and cost nearly $3 billion to sequence a single human genome. Today, the same task can be accomplished in hours for under $1,000 across every scientific discipline. Sensors, satellites, telescopes, and digital instruments are generating data at a rate which was unimaginable such a generation ago. The scale of challenges. The Square Kilometre Array (SKA) telescope, currently under construction, will generate more data per day than the entire globe internet traffic of 2020. The Large Hadron Collider produces approximately 15 petabytes of data annually. Handling, storing and making sense of these volumes requires entirely new disciplines, from data scientists, bioinformatics, to machine learning and cloud computing. AI as scientific partner. Artificial intelligence is rapidly becoming an indispensable partner in research. DeepMind's AlphaFold 2 solved the 50-year-old protein folding problem in 2020, predicting the 3D structures of over 200 million proteins, a feat that would have taken conventional methods centuries to accomplish. Similar AI-driven breakthroughs are emerging in drug discovery, materials science, climate modeling, and astrophysics. Open science and collaboration. The data revolution is also democratizing science itself. Open access publishing, shared datasets, and collaborative platforms like GitHub and R RXIV are enabling researchers in every corner of the world to build on each other's works with unpredicted speed. With the COVID-19 pandemic demonstrated its potential vividly. Within weeks of the virus's genetics sequencing being published, research teams worldwide were designing vaccines, therapeutics, and diagnoses in parallel, compressing what might have taken decades into months. The frontier of exploration. What's next? Science never stands still. Even as we celebrate past breakthroughs, researchers are already pushing into territories that challenge the boundaries of what was previously considered possible. The coming decades of promise discoveries that may prove as transformations transformative as any human in history. Artificial intelligence. AI is transforming every branch of science. In medicine, AI systems are diagnosing diseases from medical images with accuracy surpassing human specialists in chemistry. AI is designed novel molecularly for drugs and materials. In astronomy, machine learning algorithms are shifting through petabytes of telescope data to identify new exoplanets, gravitational waves, and cosmic phenomena. AI promises to compress research timelines from from decades to years, or even months. Quantum computing. Classic computers process information as binary bytes, either 0 or 1. Quantum computers exploit the principles of quantum mechanics, using qubits that can exist in multiple states simultaneously. This gives them potentially to solve problems such as simulating complex molecular interactions for drug discovery or breaking current encryption systems that would take classical supercomputers longer than the age of the universe to complete. Several nations and major technology companies are in an intense race to achieve practical quantum advantage. The future is scientific. Join the journey. Science is not the exclusive domain of noble laboratories and research institutions. It is a way of thinking, a commitment to curiously evidence and willingness to change one's mind in the face of new data. It is a deeply human endeavor, born of wonder and sustained by the belief that the universe is noble. Embracing scientific thinking. Scientific literacy, the ability to understand evidence, evaluating claims critically, and appreciate uncertainty, has never been more important in an age of misinformation and complex global challenges. The habits of mind cultivated by science are the essential Clive's tools, whether you are a researcher, a policymaker, a teacher, a curious individual, embracing scientist thinking empowers you contribute meaningfully to the world's most important conversations. The best time to embrace science was yesterday. The second best time is now. Curiosity is the only prerequisite. Thank you everyone for watching today's video. Make sure you hit the subscribe button. Bye and see you in the next video.